Hey, welcome to Chi-Square. I'm your host, Ariana, and anyway, hi, Ozzy. Okay, so this is, hopefully this will work well. I am looking at exercise 47 about cutting class and other behaviors. Oh, he's gonna start playing with a plastic bottle. We'll see how loud that is. I guess plastic bottles aren't the best to give your dog, but they're like a kid with TB. We'll deal with it. Okay, so it talks about chi-square being a test of significance of the differences among frequencies. So think about that. When we look at this table, table 1, we have behavior. We have the different behaviors and whether kids cut school or they didn't. So the differences in frequencies are numbers of the kids that cut school or didn't cut school based on their behavior. I don't know. I guess we'll just see if maybe that will just drive me insane. Plastic. Okay, so just look at that. The first chi-square test is for that first line of data in table 1, got drunk. So you see the number of kids who cut school and got drunk is 59 kids, 59 of the 68. I'm gonna blow your mind in a minute. But anyway, so 59 to 68 got drunk, which is 87% of the kids that cut school. And this is compared to only 24 kids that don't cut school getting drunk, which is 46% of that sample. And again, they're using these percentages because the sample size for the kids who cut school and didn't are different. So what you don't see here is basically these are both nominal variables, and you could consider getting drunk, yes or no, compared to cutting school and not cutting school. So I made, look at this. Okay, so what I did here, it looks backwards for me. I'm gonna assume it's not for you. Oh, look, is that, okay. So what I did, I highlighted just the part, this is what's in the table, right? Let me back up a little bit. So this is what's in the table. It's got drunk. I mean, it just says got drunk instead of yes. And it's just the information I just told you. Dude, I so hope that's not really backwards. Anyway, if it is, we'll make a memory. That's interesting. What they don't show you is the no. So if you look at that, you do see that the 59, okay, I'm pointing right, the 59 and the, yes, 9, not 6, can't read through the paper, is the 68. So that's the cutting school class, and again, the group, and then you just see over here the same thing. So to save space, I will guarantee you that when they ran the data, they got a table that I'm sure was not this lovely, but you know, they got something like this. But to save space, because you think about how many lines of data that is, and they have how many chi-square tests for however many variables that is, about 10 or 11, something like that. So that's a ton of space. You cannot put that in a journal article. So what they did was they just presented the first line of data and the chi-square test. So there you go. So that's what it looks like broken out. And again, you could figure out what the no's were for each of those behaviors. For SPED, broke the law, you could do that, but they went ahead and just gave you the people that answered yes, they did do that behavior. So that's chi-square test is comparing relationships for nominal level data, right? So cut class or not is a nominal level variable. I mean, you could say it was ordinal if you thought there was some order, but you could put cut class or not cut class first. It doesn't really matter. And the same with yes, no variables like got drunk. So now it says, I'm going back to the statistical guide, and it says the null hypothesis for a chi-square test asserts the differences were created by random sampling error. Well, yeah, that's true, but let's convert that to English. And so all it means is a null variable. I don't even know if that's a thing. A null hypothesis for a chi-square test just asserts that there's not a relationship between the two variables. So there's no relationship between cutting school status, I guess, whatever we want to call that variable, between cutting school and getting drunk. That would be the null. But you know that you only, you can't reject, see, even I get confused. The only time you reject the null is when the test is statistically significant, which means small p. And so that's what they tell you, like in the third sentence. Like other significance tests, the null hypothesis is rejected. The null means no difference, right? Is rejected, no difference, no relationship. The null is rejected when the probability that it is true is low. There's got to be a better way to say that. But anyway, that P is probability of error. So small probability error means we're pretty darn sure there's a difference. And so again, when you look at that chi-square test, it's 22.79, whatever the hell that means, right? Like, what does that mean? But you know what that means, because who is your friend? P. That's right. So P is your friend. My husband's making strange gestures. Anyway, so that's how you know, right? So you can go ahead and read through this. I'm going to show you one more table, and then what I would suggest you do is go ahead and work through the exercises to the best of your ability for 47. And I'm going to go over the answers, or, you know, work the first one, see what I say the second one, or you can cheat and just listen to the answers. I won't know. But either way, I will go through the answers. But before I do that, I want to look at your homework, which is exercise 48 in the table there. I just want to show you a couple of things. We actually glanced at the table, and you all made the point. God, all my classes are starting wrong. Oh yeah, this is actually, anyway, never mind. This was something on your, similar to what was on your homework, but we'll talk about it. On your last quiz that pained many of you. So look at exercise 48 on chi-square. It's the second one. It's your homework. And the first table is percentage of subjects for each marital status. And if you look at the table below it, that will look familiar because that's the one that was actually on your last quiz that you found confusing, and actually modified it a little to help. And of course, I asked you to look at this before you really even knew what chi-square was. So, so table 2, thank you. I did this in Excel, so maybe that's harder to see. I mean, I can give you this table if you want, but you really actually have it. This table is taken directly from table 2, and all I did was add the bottom column. I added a total. And again, this would have been in whatever data they ran. They would have gotten a table like this, but to save space, they're not giving you every single thing. So I just want to show you, again, this is these are nominal variables. So we have, again, we're going to test for the relationship, in this case, between crime type and marital status. So what we have here is a nominal level variable called crime type, and there are 4 categories: murder, robbery, theft, drug, and other. Fun, facts there. And then we have 3 categories for marital status. We have single, previously married, and married. And what you have there are the numbers and percentages. And what I did, this is the thing I was talking about that I really struggled with remembering which was a row and a column percent. And sadly, it took me until this year, 20 plus years later, to figure out, oh yeah, columns like on a house. So I would run things, and the software program would give me the row percent, the column percent, and the total percent. And I could never remember which one to look at, because you can either have a row percent so that this totals to 100, a column percent so that that totals to 100, or a total percent, which means adding each of all those numbers would total up to 100. So if I just confused you, let it go. What I really wanted to show you here is that for each of these 3 groups, they use the column percent. And how I know that is because when you add those up, they equal 100, same thing. I went ahead and just did them in Excel to make sure. And then the samples. So again, they're different sample sizes for the, can't read backwards. Yeah, for the single group, they're 41 folks as opposed to 39 in the other 2 groups. And so you have to have information for the people in this analysis. You have to have information for both variables. So I have to know your crime type and your marital status. So again, the only thing that's missing from the table is that total. So I just show you that to show how they add up, and you could do the same thing for the other exercises. When I look at the chi-square test below it for violence, they have the yes, no, and then the 3 categories. I noticed, what is that total to? 44. So the total for the single folks for violence, yes and no, there are 28 single folks who did not commit a violent crime and 16 who did. and that totals to 48, and no, 44. And what that tells us is that this sample size is smaller because they must not have had maybe the yes no variable for those people. So that's why that sample size is a little different. But anyway, so just hopefully that orients you a little here. And what you found confusing in that table 3 from your quiz was that the chi-square test was actually in the example, it's right next to drug and other. And you thought, oh, that, again, without knowing what the heck a chi-square test was, that's like where you thought the only significant difference was. So actually I moved it down here. But again, we know now that the chi-square test is looking at the relationship between, in this case, this variable marital status and this variable crime type. So that chi-square test, right there, is, again, even if you don't know what chi-square test is, you wouldn't know. P is your friend. So that lets you right now, those asterisks tell you, oh, here we go. Probably can't even see that. The asterisks tell you to go look down there, and we know that there is a relationship between marital status and crime type. Now, we don't know exactly what, because we've got 4 categories here and 3 here, but I would say that we can definitely look, and you can look